Welcome students. In this video what we're going to do is we're going to sketch a few simple rational functions, and we're going to focus on the x-intercept, the y-intercept, asymptotes, domain and range. We're not going to do so much the intervals of increase and decrease, and we'll look at the end behavior, and of course we're going to sketch them. So here we go. When you look at this is a rational function. We had said in class that the denominator is going to give you the vertical asymptote. And because this is plus 5, this has a horizontal shift to the left, right? And the vertical asymptote is going to happen at -5. So this is a horizontal shift to the left. The fact that this doesn't say plus a number, right? That there's no number here, means that it's plus 0. So that means that your horizontal asymptote is y equals 0, and we have no vertical shift. The next thing you do is you sketch your x and y axis, and then you place the asymptotes. So at x equals -5, 1, -2, -3, -4, -5. Place a dashed line that's going to represent the vertical asymptote. We're going to label it x equals -5 VA. At y equals 0, so you just do your best to put a dashed line. We're going to call this one the horizontal asymptote, y equals 0. Now we're going to sketch the graph. Remember, the graph approaches the asymptotes. You're focusing on the dashed lines. And when you do this, you notice that you're crossing here, right? And this is the y-axis, this is a y-intercept. So we'll need to solve for that. And since our graph is here on the top right, oh, I forgot to say y was in the top right. If you look here at the sign of the leading coefficient is positive, right? It's positive, an understood positive sign here. So that tells you that you're going to be in the top right, and then the other one's going to be over here. All right, well, I'm sketching more, so just keep watching if you miss or you don't fully understand one of them. All right, the only place that you cross is a y-intercept, so we need to solve for the y-intercept. And when we do this, we said that we were going to make x equal to 0 in the original function. So it's 1 over 0 plus 5, which is 1/5. So it's 0, 1/5. Let me write this in here. All right, so what kind of transformations do we have? Well, we have a horizontal shift to the left, 5 units. We have no vertical shift, and we have no reflection. Domain and range. Domain is going to be, x can be any value, but there's one value that x can't be, and the function doesn't exist when x equals -5. So x can be -5. For the range, it's going to be all reals. Y can't be, notice right here, if you look at all the y values, the function can exist at any y value except when y equals 0. So y can't be 0. All right, for number 2, I went ahead and I wrote some of this stuff to kind of save time. Go ahead and pause the video if you want to write this stuff down. And these are the things that we need to answer. So when I look at this and I think, do I have a horizontal shift? Yes, I do, because look at the denominator. The denominator tells me that x equals 3 would make this denominator go to 0. This is the VA. So for the horizontal shift, you would say yes. You have 3 units to the left. Sorry, it's -3, so it's 3 units to the right. Right, so yes, our VA is going to be x equals 3. For the vertical shift, see, you're not adding a constant here. It's not +0 or -0. So we have no vertical shift, and that means that your horizontal asymptote is y equals 0. Okay. Reflection, you focus over here in the front. You'll notice that there is no negative sign here. It's an understood positive. So we have no reflection on the x-axis, or none, however you want to write that. So now what we do is we go ahead and we sketch, and we try to draw straight lines. Remember, I've told you this is a digital pen. It makes it really hard sometimes to draw straight lines. Vertical asymptote at x equals 3. So 1, 2, 3. Our horizontal asymptote is at y equals 0. Oh, I'm going to label them right now. So VA, x equals 3. HA, y equals 0. Now I'm going to sketch the curve. And remember, we said that there is no reflection because it's a positive sign. So it's going to go in the top right. And the other one's going to go here in the bottom right. And you'll notice that we cross the y-axis. So this is a y-intercept. Notice that we don't cross the x-axis, so there is no x-intercept. But we do have to solve for this y-intercept. So then you say y equals 2 over, right? We're going to plug in 0 in here. 0 minus 3, or that y equals negative 2/3, right? So it's going to be 0, negative 2/3. Then you label it here. The domain, x can be any value, but what's the one value that x can be, right? The function doesn't exist when x equals 3. So x can be 3. In the range, it's all reals, but y can't be 0. That's a 0. Believe it or not, it is. All right, for number 3, when you look at this one, you start asking yourself, do I have a horizontal shift? And yes, you do. Look at the denominator. It says x plus 2. The plus 2 means that you move to the left 2 units. And that means that your vertical asymptote is x equals negative 2, right? You solve this for x. You set it equal to 0. X equals negative 2. Vertical shift, well, you come here. You notice that you have your fraction, but there's no constant either in the beginning or afterwards. So that means that you have none, no vertical shift, and that means that your horizontal asymptote is y equals 0. For the reflection, you look at the beginning. You notice that this is a positive, understood to be a positive fraction. So you have no reflection or none on the x-axis. That means you're going to exist in top right, bottom left, okay? All right, it's going to be normal, top right, bottom left. All right, then we go ahead and we sketch it. We place the asymptotes at x equals negative 2, so negative 1, negative 2. I'm not going to forget to label VA, x equals negative 2. Horizontal asymptote at y equals 0. We said that there is no reflection. So remember, the function is not approaching this line. The function is approaching this dashed line right here. Right? In this dashed line. You notice that we cross, so there's a y-intercept, which we'll have to find. So if it's top right, the other one is bottom left, and it doesn't cross anything. So we have no, it doesn't cross the x-axis. We have no x-intercept, but we'll have to solve for the y-intercept. And for that, we just make x equal to 0. So y equals 3 halves. So then the point is 0, 3 halves. And we label it. The domain is the x values. X can be any number, but x can be negative 2. Y can be any number, but y can't be 0. And look at me, I filled it out beforehand. Y can't be 0. All right, focusing on number 6. Sorry, I'm just going to skip around since I copied and pasted these. Number 6, the first thing you want to ask yourself is, does it have a horizontal shift? Well, you see how the denominator is just x. You're not doing plus or minus in the denominator. So there is no horizontal shift. All right, so set x equal to 0. What do you get? you get x equals 0. So that's your vertical asymptote. Do we have a vertical shift where it doesn't say plus or minus neither before the fraction, like something like this, 3 plus, right? This would be a constant. That would be your horizontal, your vertical shift. But it doesn't say anything like this, right? So that means that we have no vertical shift. And when we don't have a vertical shift, right, that means y equals 0. Do we have a reflection on the y-axis? Well, you look here, this is an understood positive fraction, so we would say none. So what does that mean for the curve? That means that it's going to exist here and here. All right, it's time to sketch it. You draw your x-axis, your y-axis, and then you plot your asymptotes. So we do at x equals 0. And you label it, because sometimes I'm not going to be able to see it on your design. So if you label it, then it's a little bit easier to find. And I know what it is that you're trying to convey in your sketch. All right, once you plot the asymptotes, you notice that there's no reflection. So your curve is going to exist in the top right. And do you cross the x-axis or the y-axis? No, you don't. So there is none, no y-intercept, none, no x-intercept. And for your domain, what's the one value that x can be? 0. What's the one value that y can be? 0. There you go. Some of you are wondering, what does this 4 do? Well, the 4 just makes it rise faster, right? So instead of being here, it'll be here. See? And it's kind of like the parabolas. It's kind of like the parabola. It's kind of like how they open or close. That's all the 4 is doing right there. All right, number 7. Do we have a horizontal shift where you look at the denominator? It says plus 4. That means we went to the left 4 units. And your vertical asymptote is x equals -4. There is no plus or minus here, so there is no vertical shift. And your horizontal asymptote is y equals 0. You notice how this is negative now? This means that, yes, we have a reflection. What does this mean? This means that the function is going to exist here in quadrant 2 and quadrant 4. And let's sketch now so that we can see the x and y intercepts. At x equals -4, -2, -3, -4. I'm going to put my vertical asymptote. BA, x equals -4. Y equals 0 happens to be the horizontal asymptote. And I'm going to sketch the curve. And we said that, yes, we have a reflection. It's going to exist in the bottom. Remember, it's going to approach the asymptotes, not the axes. And you'll notice immediately here that we have a y-intercept because it's crossing the y-axis. And it doesn't cross the x-axis. So x-intercept, none. Y-intercept, we need to solve for it. Right, we plug in 0 for x. We get y equals -1/4. So this is 0, -1/4. Domain. What's the one value that x can't be? -4. What's the one value that y can't be? 0. Let's see, number 8. Now, the first question you need to ask yourself is, do I have a horizontal shift? And here it says -2. That means that we went to the right 2 units. X equals +2. Vertical shift, yes, we have a -3. That means we went down 3 units. That means y equals -3 because we went down. Do we have a reflection? If you look here in the front, this fraction, not this number, but this one, is an understood positive, so there is no reflection on the x-axis. For the sketch, that means that the function is going to be in quadrant 1 and quadrant 3. Now we sketch. Getting better with the lines. All right, vertical asymptote, x equals 2. 1, 2. dA, x equals 2. Horizontal asymptote, negative 3. 1, 2, 3. Y equals negative 3 HA. Now we sketch the curve, and remember we said it exists in quadrant 1, and you're focusing on the dashed lines, right? So the function is going to approach this one and this one. And immediately you should notice that this time we're crossing the x-axis. So it's an x-intercept, and it's also going to be in quadrant 3. And we're also crossing the y-axis. So we have a y-intercept. So we have to solve for both of them. And as you guys can see, right, for the y-intercept, we have y equals 1 over 0 minus 2 minus 3. Y equals negative 1/2 minus 3. 2 minus 6. If you put it in your calculator, it should be minus 7/2 or minus 3.5. Y-intercept. So 0, negative 7/2. X-intercept. Now, if you gotta look at the videos and you gotta pay attention, for the x-intercept, we're solving for x, so the function equals 0. 1 over x minus 2 minus 3. We're gonna add 3, and we did this in class. You can also watch the videos and review, give you 2 particular examples on this. We have x minus 2 in the denominator, so we're gonna multiply both sides by x minus 2. So we have 3 times x minus 2 equals 1. 3x minus 6 equals 1. I'm adding 6 to both sides. And I'm dividing both sides by 3. X equals 7/3. And in your notes and in the videos, I explained that this is how you report the answer for the x-intercept. This is where y is 0. That's why we set the whole thing equal to 0. So we're going to label this. You can also Google x-intercept, y-intercept to get more information. Domain. What's the one x value that x can't be? X can't be 2. I'm going to use color this time. What's the one value that y can't be? Y can't be negative 3. There we go.